So from last week, we did this dot product and cross product. And please make sure you get a grasp the how the cross product work, right? It takes a bit practice, but here is kind of a summary of what we did last week. And please remind yourself, make sure we all got this. So when it comes to your vector analysis, we can do it accurately and quickly, right? So yeah, need some practice. Okay. So this is just to remind you. All right. Let's do this example. So it says find the magnitude of the moment about a base point. Base point O, let's write it out, where O is. Oops. So here is point O. Okay, point O. And 600 newtons. And let's also write out, here is 600 newtons. Okay. In different ways. Right, find the moment of this 600 newtons about point O in different ways. So the first way, use cross product and then solve the determinant. How do we do that? Well, position vector, and let me use this. Here is the position vector R, and this is F, which is 600 newtons, and I'll give this 2 meters, and here is 4 meters height. All right. So now, position vector R cross the force vector, that's equal to, let's write it out, use determinant. So I, J, K, and I better give it a bit more space, I, J, K. I here, and then K here. And R, position vector R, so 4 meters and 2 meters. So 2, 4. So here would be 2, 4, and because this is we are assuming 2D, so K for K component 0, 2, 4, 0. And for the force vector, we need the angle. The angle here is given 40 degrees. Okay, oops, let me do it again. This angle here is 40 degrees. All right, so it will be force. The x component would be, if you look, the x component would be cosine 40, and the vertical component, y component, would be sine 40. So let's write it out. Okay, F, I'll just use F, cosine, cosine 40. For the y component, okay, for the y component, F sine 40. Now, it's in the downward, so it's negative. Okay, negative. Running out of space, that's why I was trying to. Okay, and K component, 0 again, 0 again, right? Okay, now we can solve. So moment about point O, MO, equal to 2I plus 4J cross the, is that right? Yeah, 600, both this first term, it's 600 Newton. I cosine 40 minus this minus term here. Be careful, this minus term there. J minus J sine 40. Okay. Now let's look. I cross I 0. J cross J 0. So the only terms we have will be 2I cross the J terms and the J cross the I terms. Right, so we can write minus 2. I'm copying down my notes now. 600 sine 40 K. Why is it minus? 2 600 minus J. So I cross minus J, it's minus K. Remember, I cross J is K, but now you have this minus, so negative here. Minus 4, now it's the J cross I, 600 cosine 40, and that's K term. And this negative is because J cross I, right? I cross J is positive K, but J cross I, negative K. So this negative is coming from the J cross I. And if we do the math, you should get minus 2610 Newton meter. Okay, now just be careful. This 2 here and 4 here is meter. I skip the unit. This 600 here is Newton, right? Newton meter. Okay. In the, that's right, in the negative K direction. Right, this negative and this K. So that's the first way to do it. Second way, using the moment armed method. So again, let's write it out. This is 2 meter. This is 4 meter. This is 600 Newton. And the moment armed, let me do that somewhere else, 600 Newton, because I need to draw the moment arm. So let's draw the line of action. And the perpendicular distance, let's say this is a square enough, and oops, oh there. Okay, maybe I'll use red. So this here is our D. Okay, this is our D. Now let's try the second way to do this using the moment arm. So let's draw this diagram again. Given this is 2 meter, this is 4 meter, and 600 Newton, right? 600 Newton. Where is the moment arm? Let's try to do this. Moment arm. Actually, let's draw the line of action first. Right, this is line of action, and the moment arm should be. Now you can tell me if this is perpendicular enough. Okay, maybe let's say it is. So this is 90 degree. Now how do we find the length of the moment arm? Or let's use what we know here, right? We know this is 2 and this is 4 meters. And if I draw a line from this point, kind of divide up what we know and divide the moment arm D into 2 sections. Okay. Then, and we know this is 40 degree. This was given 40 degree right here. That means this angle here, if you follow me, this angle here is also 40 degree. And this 90, so this angle here, it's also 40 degree. So we can find the moment arm by finding this length and this length. And let's call this maybe D1 and this is D2. How about that? So let's try that. So D1 equal to 4 meter cosine 40. So 4 cosine 40. D2, can you look at D2? Now, D2 is equal to this length here. Do we have a better color? Maybe use green, this one. So that if this is 40, if this here is 40 degree, what would be the length of the green line there? Sine 40, right? Sine 2 sine 40. So I'll use this green. D2 equal to 2 sine 40. Ta-da! Then we get it. M equal to FD equal to F D1 plus D2, and that would be 600 Newton times. So if we do, if I do that, I get D equal to 4.35 meters. Check the math for me, please. 4.35 meters. The sum of the two, D1 and D2. So 4.35 meters. And that should give you exactly the same as 2610 Newton meter. And by looking at this figure here, again, if you wrap around 0.0, right, then it's again, it's a clockwise. Right, so we can write this is clockwise directions. This is also clockwise directions. So they match. They match. But be careful. I'm using negative here. Negative K. Right. So that's good. Negative K, which is clockwise. Negative K. Okay. Next, we will replace the force F by its rectangular component Fx and Fy at point A. So let's do that. Oops. So Fx, Fy. Again, this is 2, this is 4, right? So now we can write this is 40 degrees fx. Let me use another color. Fx equal to f cosine 40, fy equal to f, and this is f. F is right here, right? Don't forget, this is our f force. Oops. Sine 40. And now using Bragg-Young's theorem, we can write MO equal to FD. That just means magnitude, equal to Fx times 4 and Fy times 2. Because the moment arm for Fx is this 4 meters, and for this Fy is this 2 meters. Okay. So if we solve this, I have the number here. Oops. This could give us 460, and here are newtons, 386 newtons. Put into those terms, Fx and Fy will give us the final moment, again 2610 Newton meter in the clockwise direction. Okay, our last method by the principle of transmissibility. For that, let's draw a line again along the line of actions. So I'm going to start, let me guess, probably from here. Okay, that's not bad. I can live with that. Maybe slightly move over. Okay, that's better. Okay, that's the line of actions. And do another one vertically from point O. All right, and then another one from point O. Okay, so what we do now is to move this F vector, and I'll draw one on top of this so I can move it, right, to, oh, and delete a big one maybe. There you go. Move it to point B, and this is point B right here. Right, here is point B. And move another one to point C. Oops. Point C right here. Okay. Now we can break it down into the Fx component, the Fy component, the Fx component, and the Fy component. And the reason is this Y component is going through point O, so has no effect on the moment. And this X component is going through the point O, again, no effect on the moment. So we only need to worry about this Fy times the distance, and let's call it maybe distance dx. Let's use dx. And this fx times this vertical distance, and let's call that dy. And we have already calculated the fx and the fy, right? So let's write it out. Where's the so my dx is equal to, oops, you cannot see, dx equal to let's see, dx is 2, this is already given, plus what would be the distance from here to here? Well, we know the vertical distance, this is 4. We know that is 4. So if we know 40, this is 40 degree, that means here is also 40 degree. So to find this distance here would be tangent, opposite. So I want tangent 40 is equal to 4 dx prime. So we want 4 divided by, is that right? I see. We can use cotangent 40, and then that would be easier. Dx prime divided by 4. So my dx is cotangent 40 times 4. So let's write it out. Dx is 4 cotangent 40 degree. And dy, similarly, this dy here equal to 4 plus this distance. And how much is that? Well, if we know this is 2, I'm going to read my notes so I don't get confused. It will be 4 plus, and don't forget about plus the 2. And here it's 2 tangent 40 degree plus 4. Okay. So now we find our dx and dy. So dx is equal to 6.767 meter. Our dy is equal to 5.678 meter. So now we can write our moment. Our fx times dy plus fy dx. Okay, so it's 2610 again, of course. Okay.